Take one. Action.
So this is take one of a new lesson. It's a wonderful new lesson. I can't wait to share with you. This one is called Reciprocals and Negative Exponents.
What?
Reciprocals and negative exponents. So we've talked about reciprocals. Can you remember what a reciprocal is?
No.
As you can see, I do not let them like review or warn them about what they're about to sit in on. That's not very nice of me. So reciprocals are something maybe you haven't understood what they were, but you've heard that word. When we're looking at dividing fractions, when you divide a fraction, the trick is that you multiply by the reciprocal. Do you remember that now?
I think so.
Abby, who's off camera, says she thinks that sounds familiar. It's okay if it doesn't sound familiar. That's a trick that sometimes you learn from a parent or from maybe Khan Academy or somewhere like that, because that's how we were taught as children. I say we as in your parents and the adults were taught just the tricks on how to do it, but not how it works. But Montessori is amazing because we have these lessons that actually show you how it works. So we're going to work with that today. So I want to show you this wonderful new equation. We are going to work with 3 to the third, and we're dividing by 3 to the fifth. So we have 3 to the third power divided by 3 to the fifth power. Now, we know a shortcut to that because we did a lesson on what to do when you're dividing exponents with the same base. Now, I want you to hold that thought in your mind because I want to show you what we're going to do with the material. Selena's like, I already know. I know what to do. Now she heard the name of the lesson. Now she's ready to go. Okay, so what does this equation equal? Like when you're thinking about this and we know our trick for dividing, what does this equal?
3 to the second. No. Yeah.
Yeah.
Wait. It's. Wait. 3's first instead of 5.
The 3 is first. 3 cubed divided by 3 to the fifth. So when you're dividing with exponents and your base is the same, you subtract. Yeah. So what is 3 take away 5?
-2.
-2. They had to think about that one a lot.
What?
3 to the -2. I thought her connection had already been made, but
I didn't realize that the 3 was first.
So here we have 3 to the third power divided by 3 to the fifth power equals 3 to the -2 power. So now we need to figure out, what does that mean? What does a -2 mean? Okay, so here, what we need to figure out what we do with the negative exponent. So to get rid of a negative sign in an exponent, we have to put a 1 over that value. And I'm gonna slide this out of the way. I should slide it so you can still see all of it. There we go. Okay, so here we have this. I'm going to rewrite it so that you can see what I'm talking about here. So we have 3 to the third divided by 3 to the fifth, and that equals, remember I said we're going to put a 1 over it, 1 over 3 squared, 1 over 3. So we've made it into a fraction there. 3 to the third power divided by 3 to the fifth power equals 1 over 3 squared, 1 over 3 power. So now our problem is asking how many 3 to the fifths are there in the third power? How many 3 to the fifths are in the third power? And we have to look at this as group division. So when we're going to do this, we're going to look at each of these parts. So hang on one second. Okay, so we've got all of our pieces here, and I'm going to set our 3 cubed out of the way because we're not working with that. We're working with 3 to the, we're looking at our 3 to the fifth power. We're looking at our 3 cubed, and we're looking at how many 3 to the fifths there are in our 3 cubed. So we have to look at how many pieces, how many parts there are here. So remember, how many pieces, how many squares were in our 3 to the fifth?
27.
There's 27. How many 3 squares are in our 3 cubed? 3. So we're looking at 3 parts of 27 whole. What is 3 divided, so I said the same thing again, didn't I? Selena and I were talking just a minute ago when I said what is 3 divided by 27, and she asked me if that's what I meant to say. That is what I meant to say. We have 3 27ths when we're looking at 3 cubed within 3/5. That is 3 27ths. And if we reduce this down or simplify this equation, 3 27ths. How do we reduce the fraction 3 27ths? So Abby?
1/9.
Abby says it's equal to 1/9. 3 27ths, we're looking at 3. The whole has 27. It equals 1/9. Let's check our first equation. Is Abby right? Is 1/3 squared 1/9? Is 3 squared equal to 9?
Yeah.
It is. So when we're looking at dividing exponents, but we end up with a negative exponent, we end up with part of a whole. We don't end up with a whole. We end up with a fraction. We end up with part of a whole. This is what happens with negative exponents and how we end up with what's called the reciprocal. So in reciprocals, you're normally just told when in a reciprocal to flip the number over. But here you're seeing how we did that. We looked at the parts of the whole and we looked at the parts that we are considering. So the parts in the whole in 3/5, 3 to the 5th, we had 27. And here in the 3 to the 3rd, we had 9. So not 9. Yeah, 9. 9 27ths. That didn't sound right. Where's the thingy? Yeah. Take again.
Take 2.
We're not going to restart the video, but the whole part has 27. The part we're considering has 3. 3 27ths gives us 1/9. And so when we're dividing with exponents, when the base is the same, and we end up with a negative exponent, that negative exponent gives us our reciprocal. So reciprocals are really handy when you're dividing fractions. And so I hope you learned something new with negative exponents and dividing and looking at the reciprocal. Goodbye.